clear out of that. And it's recording. All right. So this is 2.1. It's called objects, which are instances of classes. But we really haven't talked about objects or classes yet. So if you know what object-oriented programming is, that's great. If you don't, we're going to introduce it. There are object-oriented programming languages, and Java is one of them. It says, what are objects and classes? It says Java is an object-oriented programming language that can be used to model objects in the real world. Okay, there are different types of programming, and object-oriented is usually what you first learn in an intro to computer science college level class. We talk about how objects are created from classes. And it says, we've seen that Java programs start with public class. When we first started writing our classes in the beginning, all of last week, when we were taking the mixed up code and the blocks and putting them together, we always started with public class, and then we named it example 1, or whatever the example asked us to name it. And it says a class is used to define a new data type or a blueprint for objects. They use the word blueprint. I used the word template earlier. And we're able to create different objects based off of the blueprint that we've created. If you don't know what a blueprint is, let's say you're building a house. Typically, you have a blueprint before you even start building the house of what that house is going to look like. Every single thing is laid out and broken down and deconstructed and decomposed into small, little, tinier steps. And then that blueprint can be replicated somewhere else. Right? You ever drive through a neighborhood and a lot of homes look exactly the same, or you might go over your neighbor's house and that's exactly the same way my house is set up, right? It's not a coincidence. It's the constructor who was building the home was able to take a blueprint and replicate it. And there's a picture down below, and it says using a cookie cutter to make cookies. And the cookie cutter is the class, meaning the template of what we're trying to create. And then the actual object that's created is the cookie. So it says objects are the variables created from the class definition. Okay, so the class is spelled out very specific of what is wanted, and then you're able to create something based off the object. Now, the purpose of this is to save time. Can you imagine just designing a bunch of cookies by hand every single time and not having that easy stamp, right? The reason why we create classes is to save time. Computers are meant as a tool to help us, not hinder us. Okay, so they are instances of a class. So objects are instances of a class. That's why it says at the very top, 2.1 objects, instances of the class. We've created string objects in Unit 1 using the string class. We didn't know it. We knew we had these variables, this data type called a string. We talked about doubles, we talked about ints, and we talked about Boolean data types. And then we briefly touched on strings. And if you remember correctly, I said, we're going to touch on this later and we're going to expand on this. You don't have to know too much about this. Just know that it exists. So a string actually comes from the string class, right? So, if we're creating a variable, we would say string, declaring the variable, string name. It's not initialized, but we create a variable called name and is a string. So it says in this unit, we'll work with a class called turtle. And the turtle class is used pretty often to deal with objects, and we move objects around. There's a turtle class also used for Python that I teach in my other AP Computer Science Principles class. And it says for animated turtles as well as the string class. In Unit 5, you'll learn to write your own classes. So you can create classes that are then used to help make things easier in the future, right? We always want to make things easier for ourselves. And the same way that we're able to copy and paste our code when we write, we're able to create templates based off of what specifications we've already set. So it says You can think of a class like a blueprint or a cookie cutter is used to create cookies, which are objects, and can create and be used to create many cookies if wanted. Imagine that you are writing a program that accepts new user accounts. Like you're creating a new account and the user types in their new username and new password, and it saves that, right? That class is storing and asking for a new username and a new password for every new account. And if we have to rewrite the code every single time that we're creating a new account, that becomes a problem. We want to use a class in order to have that blueprint of what the expectations are. Okay, so it says you can think of a class as the type or classification. Each type can have attributes, okay, the object's properties. So whenever you see the word attributes, think of its properties. So if you have an object and it is, I'm thinking of like app development, right? And you create a button. Imagine that you're creating an app for an iPhone, and you create a button, which would be an object from a class called buttons, right? And when you have that button, there are different properties that button could have. It could be a circle button. It could be a square looking button. It could be a blue button. The text on the button could be bold. It could be underlined. It could be a certain font size. These are all of its properties or attributes. So when you think of a person has different attributes. If you ask for their height, their weight, the color of their hair, where they go to school, these are all descriptive properties or attributes of an object. So, we create these objects to simulate real world objects and different behaviors on what the object actually does. And we'll talk more about behaviors here soon. And it says in Java code, the attributes are written as instance variables in the class. We'll talk more about that. And the behaviors are written as things called methods. Okay, what a user actually does. And we'll be diving into this. This is just introducing it. It's throwing out some new vocab, not too important right now. Just identify that we're going to be working with attributes and methods. Okay. The following picture has lots of cats. And it says objects of the type cat. All right. They are all different, but they share the same attributes and behaviors that make up a cat. They are all instances of imaginary class called cat, right? With different values for their attributes, right? So you could describe each of these cats. You know that they're cats, but there are different attributes or different behaviors that each have. It says they are all instances of a cat with different values as their attributes, for their attributes. Name some of the attributes and behaviors of the cats below. So it says like this behavior is this cat is playing. It could be sleep, right? The color of the cat. It's a black cat. It's a gray cat. It's an orange looking cat. I think it's orange. Orange is red. Okay. For example, the color attribute could be one of the attributes. The first, this cat is black. It's the color of the cat. And it is playing. It would be his behavior. All right. So attributes and behaviors. Attributes are the properties. Okay. Behaviors are what it does. It says discuss with your class what are some of the attributes of the cat, what are some behaviors of the cats. All right, so I'll just write this out. I'll say attributes. I can say I don't know, tail length would be one. I'd say color of the cat. Making this up, I could say the height of the cat. I could say what else would be different? Maybe the shape of the ears, ear shape, even though it's not much there. I can say weight, right? These are all different attributes. And then if I were to list some of the behaviors, I'll zoom in a little bit. Some of the behaviors of the cat. I could say they're sleeping. I could say playing. Maybe I'll just, instead of using ing, I'll just say play, say sit. I'll say, I don't know, run. I'll say jump, right? These are just different behaviors of what they can do. Okay, so imagine you're playing a video game and you click A to jump. That would be a behavior or a method that every single time you click that A button, that the character actually jumped. Have you guys ever played Mario Party before? Right, some of you guys. I played Mario Party for the first time on Friday. I'd never played Mario Party before. My sister-in-law came over and brought over her Nintendo GameCube from when she was a kid, and we played Mario Party, and I didn't recognize anything. It was a completely new experience for me. But you know, there's different games and different buttons for each game. Each mini game was a different method or a different behavior. And it changed. Like in one game, jump could be A, and the next game, jump could be B. And you just had to learn the different behaviors or the different methods of each button. I'll save it, and it says I answered it. It says watch this video. You guys can watch it if you would like. I'm just going to click it and then pause it. Okay, so it says drag the definition from the left and drop it on the right concept. It says define what the object knows about itself. Define a new data type that is like a blueprint. Define what an object can do, and a specific instance of a class. Okay, so we talked about a new data type that is like a blueprint. We said that was a class, right? Define what an object can do. We just went through behaviors and methods. Okay. Define what the object knows about itself, right? Those are different attributes. And a specific instance of the class would be an object. And if I check it, you're correct. All right, so an object, a specific instance of a class with defined attributes. Attributes are instance variables. Define what the object knows about itself. The class defines a new data type that is like a blueprint. And the behaviors, methods, define what an object can do. Okay, how many objects can you create from a class in Java? As many as you need is the correct answer. Right, there's no limit. It's limitless. What specifies the behavior for objects of a class in Java? Okay, what specifies the behavior? Okay, and that's what's inside the method. Okay, methods, whenever you see behavior, also think methods. We're going to create methods. Remember how we said the main method? What's inside the main method? The main method is where the program starts. Public static void main string args. And then we have our main method. I've been saying it, but I haven't been clarifying what a method is because we haven't got to methods yet. What are the data or properties of an object called? The properties associate that with attributes. Right. Okay, so it says intro to object with turtles. Look at this turtle over here. Right. We have an object, this turtle, and the turtle has a name. The turtle has a width, a height, a color, and then I can define different methods. A forward method would, I'm guessing, make it go forward. Turn left method makes it turn left. Backwards makes it go backwards. Turn right makes it turn right. Just based off of the very clearly named methods. So these are the methods. Usually methods have open and close parentheses next to them. And then these are the properties or attributes, right? The name of the turtle, the width, the height, the color. These are all ways we can define what that object does, right? So that's a nice way of thinking of it. I like that visual. All right, so it says intro to objects with turtles, 2.1.2. It says the turtle class that we've written for you and hidden on this page is a blueprint for turtle objects. The awesome thing about programming is you don't always need to know all the ins and outs of the APIs that you download or the classes that you're using. You just need to know what they do and when they're supposed to be used. You don't always need to know the why. You can learn the why and you can learn in depth of all the code that goes on behind the scenes, but you don't need to, okay? You don't always need to, especially when you're first starting the program. Because if you try to figure out the why early on, when you start working with this stuff, you might get lost and might just get entirely disinterested because you realize how complex it can be. But if you learn the what's and the when's before pursuing the whys, you can always pursue the why of why we're doing this. But you might get a little lost along the way. So we're taking this in bite-sized pieces. It says it defines attributes for graphical turtles, like their color and position and methods. So it says try the Java program below. And we're creating a turtle object called Yertle the turtle, using the turtle class. All right, so it says try clicking the run. Remember how I never read properly, so I should probably read this. Try clicking the run button below to see what the following program does. If the code below does not work or it is too slow in your browser, you can also use the turtle code in Replit and it creates a link for you, okay, or download the files here. So notice, here's some of the code. I like walking through the code. It says import. We haven't talked about what import does yet. And we're importing java.util.asterisk and then java.awt.asterisk. We're importing these things and we don't have to know why we're importing it right now. You just need to know what it does. Okay. We want to import, and it'll talk about it. I'm sure it will explain some of this code later on below, but we want to import these two lines. We want to use this import in order to utilize the turtle class. Okay. So it says we're going to create a class called turtle test. We're just creating it. We have open parentheses. We wrote our main method, which we're used to. So far, so good. And we're going to create a world, and we're going to name it habitat. Just like how we used to create a data type, we'd say like double and then name the integer or name the variable. We're going to create a new world and we're going to name it habitat. And then we're going to use this keyword new, and then we're going to assign the space. It's going to be a 300 pixel by 300 pixel space. Okay. And the way we would create that is just by writing world and 300 by 300. Like I said, we're just using this turtle class. This is just bear with me here. You might have no idea why we're doing this, and you'll see later on. Then we're creating a turtle called Yertle, and we use this keyword called new again, and we throw this turtle into its habitat. Okay, we then move it forward, we turn left and then move forward, and then we show it. All right, so if we run it, here's what happens. Check it out. So it's pretty slow and choppy there, but the turtle started off facing forward or facing up. It moved forward behind the scenes. Forward was determined to move a certain amount of pixels forward. The space we determined, this must be 300 by 300, right? So in our new world created a white box. When we create our new turtle, it created an object that looked like this. It moved forward a certain distance in this line right here. It then turned left and then moved forward more. Okay, don't get too confused by this. This is just demonstrating how to use the turtle class, which we won't do very often in this class and in this Java class, but it's important just to see what's actually going on. All right. And it says in the following video, it shows the program creates a world. I'm not too interested in that. It just walks through and explains exactly what I just explained. Okay, so now it's going to attempt. Hold on one second. Maggie Convoy is not my class. Not one of my students. Period 6. Honors Java. Nope. Not in my honors Java class. This is not Mr. Thing, it's Mr. Danza. Thanks, bye. Anyway, so we're going to explain some of this code, okay? And the first thing it mentions is the dot separator, okay? Same person is called. No problem. They call again. Anyway. All right, so it says here, the dot separator is used to run an object's method. So check this out. This forward method, remember how we defined, like behind the scenes, it defines what forward does. But that dot separator, it says, hey, we're going to use this turtle named Yertle, and we're going to move Yertle forward. I don't know how many pixels it is, but what's that? There you go. And then it turns left, but the dot separator defines, or it says, hey, we're about to use one of its methods, right? So it's used to run an object's method. You can think of the dot as asking the object to do something. Okay, so it executes it. So you'll name it and say, hey, you put a name to it, right? It says, hey, like Mr. Danza, move forward. Or hey, Yertle, move forward, and ask the turtle, Yertle to go forward. There, it says it right there. It says it doesn't tell Yertle how much to go forward. So it goes forward 100 pixels by default. Okay. The parentheses after a method name are there in case you want to give the method arguments. Okay. And you can give it certain arguments, certain data to do its job. That's what arguments are. Arguments are different from parameters. We'll talk about parameters later on, but arguments are data that you're pushing forward to you're pushing to the actual method. Okay. It's accepting that data that you're putting in there and already predetermined behind the scenes knows what to do with that data. So if you were to type in Yertle.forward 50, instead of moving forward a default of 100, it will move forward 50 pixels. It says try changing the code to go forward 50 pixels and then run again. So if I move forward 50, and then I don't know, let's say we move forward 300, let's say 200. It might go off the screen. We'll say 150. All right, so if I go back to my code and rerun it, notice how it went forward 50, it turned left, and then went forward 150. And a lot of times the arguments that are passed inside are not predetermined. A lot of times the arguments are based off of let's say you're playing a video game, right? It's not going to predetermine your path. The user is going to be submitting input via the controller or whatever keyboard or whatever device you're actually using as the data is being accepted. And then what's going on behind the scenes is that's being taken in as an argument and then processed in the method. It says try changing the code above to go. We already did that. Which way does a turtle face when it was created? Well, it looked like it started off just naturally facing north, right? So if you don't set, the default is going to naturally face north. Okay. What type of thing is Yertle in the program above? Yertle is an object. We created an object from the class turtle. We could create multiple turtles on the same screen if we wanted to. What type of thing is turn right? Turn right is a method. It's what it does. What type of thing is the position of the turtle in the world? The position, it's not an object, it's not a class, it's not a method, it's the attribute, it's the location, it's something that describes the turtle. Okay. It says the following program uses a turtle to draw a sort of sideways capital L as seen in the image. Okay. But the lines of code are mixed up. Let's see here. It says the program should do all necessary setup, import items, blah, blah, blah. Then it should ask the turtle to turn right, go forward, and turn left. All right, so I'll just set this up first, and then I'll reread things because, like I mentioned, I'm not the best at reading. Public class turtle. Before I do that, I'm going to import all this stuff. I'm going to import java.util. And the asterisk is typically means all. So I'm importing everything that's in util, and I'm importing everything that's in AWT. We'll talk about what that is later. Okay, I'm going to close my main method in class so I don't forget, and then I'm just going to put things in the middle here. I'm going to first declare and create a new world, and then I'm going to create Yertle. And let's see what I want Yertle to do. It says it should ask the turtle to turn right. We've determined that isn't that what we named it before? Turn right. Yeah, okay. Just making sure I was on the same page. So turn right, and then we want him to go forward. Yertle dot forward, this one. Make sure the semicolon's at the end. And then after he moves forward, we want him to turn left. So Yertle turn left. And then after he turns left, go forward 50 pixels. Okay. Next, it should ask the habitat to show itself. So if we're looking, right, habitat.show, we're using a capital T or a lowercase t. If you look back what we use at the top here, we use a lowercase t because that's the keyword that's being used in Java. Okay, lowercase t is being used. Whoops. There you go. It says, finally, it should close the main method, and I believe we did that. All right, so let's run it. Let's see if I got it right. This is what it looks like. 1, 3, 9, 6A, 8B, 7, 10, 2B, 4. Perfect. All right, it works. Okay. It says in the code below, Yertle goes forward and then turns left. Can you change the code to make Yertle go forward twice and then turn right? All right, so I mean, I could say Yertle.forward. If it was going forward 100, I could just type 200 in there, but I think it wants me to actually write two methods in there twice and then turn right. Let's save it and run it. All right, it passed. Okay, creating turtle objects. When you write a class, like the turtle class, we're using the class that someone already created for us, this turtle class that exists. Someone made that for us. You can create many objects of that class type. You can create many different turtles. Yes. Yeah, that's fine. That's fine. Awesome Chromebook we got. In the code below, the two turtles are created Yertle and Myrtle. You can name your turtle and add in a line like the following in the main method to make it move. Okay, so it has turtle and then your name turtle. We create the new turtle and put it in the habitat. All right, so it says, can you add another turtle to the code below? So what I can do I can create a turtle. I don't know if it actually wants me to make it do anything. I'll say Steve. And we'll say new turtle. We'll put it in its habitat. And then we'll close that, right? I don't know if it wants me to make it do anything. It just says, can you add another turtle? So I'll run it. All right. So yeah, that's all I need to do was create another turtle. Right. So it naturally changes the color of the turtle. We've got a green one, got like I don't know what color you want to call that. Turquoise. And then like a magenta looking turtle. Okay. Here's a class that shows some of the attributes and methods of the class turtle. All right, so we can use these methods that already exist. We didn't write these methods, right? The pen up, pen down is what actually draws the path that's going on. It must, as a default, already have the pen down. So if I want to lift the pen up and you don't want to track what it's drawing, you can do that. You can make it move forward, backwards, forward a certain amount of pixels. That's if it's accepting arguments. And it's saying, hey, look, when you actually move it. So we left off at 2.1.4 and it says programming challenge, turtle drawing. And I guess none of that code ended up saving, which is fine. But we will, I guess, just go ahead and start this. And it says 2.1.4 programming challenge, turtle drawing. It says we encourage you to work in pairs, but you don't have to. A lot of the stuff with CSAwesome, it encourages group work. We're working through this together already. So we're creating a turtle object and we're having it draw different shapes, and it gives us very specific commands. It gives us some methods that we can use right here. Okay. And it says create a turtle object in the habitat. And just as a refresher, when we were up here, we created a turtle object by writing this line right here. And we had named it Yertle. I'm just going to copy it, right? Just so that way we have it already. And I'll go ahead and paste it. We create a world called habitat, and we put the world in a 500 pixel by 500 pixel square. And then we create a turtle. You can name it whatever you want. I think the other day I named it Steve, right? I said turtle Steve is equal to or assigned a new turtle. Okay, you're calling the turtle class, and you're going to put this turtle inside the habitat that you just created. Now, you could have named this whatever you wanted. They just named it habitat, and we're using it in habitat. All right, so we create a turtle object, and it says have the turtle draw a small square. And we discussed how maybe we could create a loop and write a loop that automatically creates that square. But what they want is, we haven't talked about loops yet, so I'm not going to confuse some of you quite yet. We're going to make it move forward, and I'll say forward 20. Okay. And then we'll have Steve turn right. Steve turn right. And I'll make him, after he turns right, I'm just going to copy this code. I zoomed in a little bit so you can see it. All right. I'll just copy this. He's going to move 20, turn right. He's going to move 20 and turn right. And then finally, he's going to move 20 and turn right. And by then, he would have completed one square, right? We have 4 sides, each at 20 pixels. Now, notice that we're just taking forward, turn right, forward, turn right. If we had talked about loops already, which we will, I believe, in a few weeks, we would be able to use a loop instead of writing all that code and make our code more efficient and not using up 8 lines of code when we could have used 3 lines of code maybe. All right, so you can add a semicolon after all the turn rights, because I didn't originally do that. All right, and then it says have the turtle draw a large square. So I could just go through and maybe instead of 20, I'll add 50. Okay, so I'll copy and paste all of these 4 times, right? So it's going to move forward 50, turn right, move forward 50, turn right. And it says play around. And play around, if you look at some of the methods that it offers, I can pick my pen up. I can move backwards. I can turn left. I'm just gonna, it will run either way, but I'll just say Steve, I'll just say pen up, right? So pen up, Steve.pen up, and it picks the pen up. And maybe I'll move Steve dot forward. Maybe I'll move forward 60. And then I'll say Steve dot pen down. And I'll put the pen back down. And maybe I'll just draw a small square, really, really small, maybe a 10 by 10. So I'll copy this. So that's 1, 2, 3, 4. All right. So if you didn't see what I just did, okay, I'll zoom out and I'll take a look at it. So it says have the turtle draw a small square, and I drew a 20 by 20. And then it says have the turtle draw a large square. I did that. I drew a 50 by 50 square. And I played around by picking the pen up. I moved forward 60. I then put the pen down and drew a 10 by 10 square. And maybe then at the end, I'll just say pen up. I'll pick the pen up. All right. So I'll run my code, and here's what happens. Compiling and running your code now. All right. So my turtle draws this square, and then it draws a 50 by 50. That was originally a 20 by 20. And then I moved forward 60, and then I drew a small 10 by 10 square. So the pen up allows me to pick the pen up and not attach. If I were to look at this turtle right here and maybe move him out of the way, you would be able to see that these squares are not connected. This square right here is not connected to this square by using the pen up. It picked the pen up. It's like imagine you're actually writing something and the pen is down, and then you're actually picking your pen up. All right. And then at the end, I guess, the part that was at the end, it showed the habitat. It's a bit slow. It ran it. It's a little slow running. I'm guessing just because we're using this online IDE. All right. So 215 summary. We talked about classes, talked about objects. It says a class defines a new data type or classification. Okay. It is a formal implementation or a blueprint. We talked about how classes are used to repeat things and how we can create objects from these classes, these templates that exist. Okay, we can create our own templates, or we can use these classes that already exist, like the turtle class. Someone created the turtle class, created some methods that we can use, and allowed us to draw using the turtle class. And says, the class also includes its attributes and behaviors. An object is a specific instance of a class, okay, with defined attributes. Objects are declared as variables of a class type. All right, so any object that we create comes from the class that it represents. If we have a class called dogs, we could create different objects from the dog class that are different, right? We know that a husky, my favorite type of dog, I like Siberian Huskies. Huskies are dogs, labs, poodles, whatever dog that you choose, they're all part of the dog class, but you can create different objects from the dog class. It saves us time eventually. Okay, attributes and instance variables is data the object knows about itself. Okay. Another word for attribute would be property, right? The properties of it. We talked about people and how we can classify them and take different attributes or properties about them in order to describe them, as well as any object. For example, a turtle object knows the direction it is facing or its color. All right. And the last thing we talked about was the behavior, also known as methods. It's something that an object can do. If you remember, I'll scroll up here to, okay, here we go. We talked about the turtle class and how we can move forward, backward. We could set the color of the turtle, the width. These are all methods that we could use in order to change it. Its attributes or its properties are listed up here. Okay. It says this video shows another class called belt and how it has 3 instance variables. Don't worry about that. I'm going to click play just so it shows that we've played it. It's a minute-long video. You can watch it if you want. It says, try these AP practice questions. A student has created a dog class. The class contains variables to represent the following. Okay, a string variable called breed, an int variable called age for the age of the dog, and then a string variable called name for the name of the dog. Okay, it says that the object pet is declared as type dog. So it comes from the dog class. Which of the following description is accurate? An attribute of the name object is string. An attribute of the pet object is name. That could be one, an attribute of the pet object. Okay. An instance of the pet class is dog. No, it should say an instance of the dog class is pet. An attribute or property of the dog instance is pet. No. An instance of the dog object is pet. It's not a dog object. It should say instance of a dog class. So the one that made most sense to me was an attribute of the pet object is name. Let's see if I'm right. Correct. So we'll continue to learn more about the verbiage. If it still confuses you, that's fine. We'll be talking about it a lot. A student has created a party class. The class contains variables to represent the following. An int variable called num of people to represent the number of people at the party. Right, we have 1, 2, 3, 4, 5, 6, 7 people in class right now. A Boolean variable called disco lights on to represent true or false whether the disco ball is on currently. And a Boolean variable called party started to represent whether the party has started or not. So that would be a true or false. Okay, it says the object my party is declared as type party. Right, let's say you throw multiple parties throughout the year. You throw a party for 4th of July, you throw a party for Memorial Day, you throw a party for Easter, you name it. That's all from the party class, and then you can create objects from that party. All right, so it says, which of the following descriptions is accurate? Boolean is an attribute. No, Boolean is a data type. My party is an attribute of the party class. No, my party is an object. My party is an instance of the party class. That seems true. My party is an attribute. Nope, it's not an attribute. Num of people is, it's not an instance. Num of people is an attribute of the party class. Okay, so, or sorry, of the party object. So it says my party is an instance of the party class. That's true. So it should be C. Okay, it says you have attempted 17 of 17 activities on this page, all the way green, completed, well done. And that is 2-1 objects and instances of classes.